I'm Greg. This is my shop. This is my first video that I'm ever making for YouTube, so if you're watching, you are currently witnessing history. Very unimportant history, but it is history. This video is going to be me making the bead roller that Carl Fisher made on his channel, Japhands Kustoms. If I can figure it out, I'll put a link to his channel down in the description. But again, this is my first video, so cinematography is going to be terrible, camera angles are going to suck, editing is probably going to be terrible. But this is going to be a quick overview of me building the same bead roller that Carl Fisher has put plans out for, slight modifications, which will all be shown in the video to follow. If you have any feedback, I'd appreciate it. And thanks for watching. I have no official intro or outro, so this is basically all I have at this point. Hopefully over the course of time, my video making abilities and skills will improve. That'll be kind of interesting to see how that journey goes. So thanks for watching. So I'm gonna apologize for the audio right now. I don't have any good mics yet, and if this ends up turning into a more regular thing, I'll go out and invest in some mics, but just figured I'd do a quick little voiceover on a few of these time-lapse sections. This section right here, I'm just going through and I'm getting all the drawings and layouts onto my cut sheets for the plasma table, and then after all of the drawings and things are in the cut sheets, you then run it through sheet cam to generate my G code. I just check my G code over real quick before I dump it into Mach 3, and then once it's in Mach 3, I run through the cut real quick and generally get everything squared away in Mach 3. So here's a section where I'm just going through getting set up on the plasma table, and here's a shot of some of the cuts. I'm not going to go through all the cuts here for you because that's a little time consuming. And now here I am going into Fusion 360 to do a quick drawing and layout of the bearing blocks. So unfortunately, I don't have a manual milling machine, and some of these things are just so much faster to do on a manual machine because you don't have to go through all this CAD stuff. But I only have the Bridgeport Boss 5, so I have to do all of my machining like this. I have to get the G code put together. So it's been a little while since I used Fusion 360 and set up any of the cam section, so I had to run through a couple little iterations before I got everything squared away. Generated the G code, and then in a little bit here we'll go into the video portion that shows roughing out and then doing the finished bore on the bearing blocks after pre-drilling, because I did pre-drill, and all the pre-drilling I did on the Boss 5, but I used it more or less in a manual mode. I ended up getting a single piece of 3/4 by 2 cold rolled steel, about 12 inches long, and then just used my old horizontal bandsaw here to hack those up into the 3 individual pieces. And here we are running through a fast forward of all the pre-drilling work. I ended up calling the upper right hand corner my 0. So what I did once I zeroed out the first piece, I just kept that same 0, and I just roughly lined up each block with the fixed jaw on the vise, so I could I maintain my 0 close enough for, you know, the precision needed on this, and then I was able to just swap the blocks out relatively quickly. So my finished pre-drill is a 1-inch pre-drill. The bushings are roughly 1.25 inches on the OD. So this basically meant once I got through with the 1-inch drill, I only had to circle mill about 1/8 of an inch off of the side. I did that in multiple passes, as you'll see in the video coming up here shortly. So unfortunately, this mill being old and not having any kind of automatic tool changer, the tool changes are a little on the painful side, which is why I tried to do each tool on all 3 blocks, because it was a little bit quicker and easier to swap the blocks out and stick with the same tool. this portion, it was the same tool for all of the work, and being able to actually circle mill these is actually a pretty nice way to get them to size. Although the boring head on a manual mill will definitely do every bit as good a job. This I ended up doing multiple passes on the roughing pass and the finish pass, which was a little bit of a waste of time. I probably could have been fine with a single pass on the roughing and then a multi-pass on the finishing. But as you'll see shortly after these are done being machined, the fit actually came out to be a very, very nice press fit. And then I just had to use a little internal flap sander to touch up the bushings once they got pressed into place. So that whole process worked out very nicely. And then just a quick little press in on my kind of crappy little homemade hydraulic press. Presses them in nice though. So here's a quick time lapse of me just going through and getting everything set up and welding it in. My center bars warped a little bit initially when I cut them out on the plasma table. So did a little bit of manual straightening. Once the manual straightening was squared away, they went right into the tab and slots, and I just made sure everything was nice and square, tacked it all together, got the one side on, put the other side on, basically fell right into place. Tacked that all together, and then off camera I welded the perimeter 1/4 by 2 inch flat bar onto the outside. And here we're just taking the two 1 inch shafts and turning the ends down that are gonna be the ends that the rollers go on. Turn them down to, I believe it's about 7/8 to fit all the dies from my Harbor Freight bead roller. The other end of the bar doesn't have to be turned down because the gears that came off of the Harbor Freight bead roller are actually almost a 1 inch ID. I had to open those up just a very little bit to get them to fit onto these bars. But once I got them opened up, they fit right on, welded them in place, and we were good to go. Here I'm just real quick drilling and tapping the hole for the adjuster plate that raises and lowers the upper die on the bead roller. Just drilled the pilot hole, tapped it, tilted the block a little bit, and milled an angle into it just so that it would go down and meet up with the 1/4 inch flat bar. Didn't want to have a huge step in that. Really no point in doing this at all, just kind of something to do. This is my version of the Japhands Kustoms custom bead roller. This is basically what I built using the plans that Carl Fisher had put online. The only place I really deviated from his plans was the motor assembly. I tried to save a little bit of money and used a 1841 ounce-inch NEMA 34 stepper motor that I had on a shelf that was originally something that I'd retrofitted onto my old Bridgeport Boss 5 milling machine. And then I ended up replacing it with hybrid steppers so that I actually had some feedback. So this is the stepper motor and the bracket that I made to hold it on. The sprocket assemblies that I had put together. This is the little aluminum electronics box that I built for it. Basically all parts that I had already on the shelf, except for that little guy right there, which is basically a pulse generator to create a signal to drive the stepper motor driver. I had taken the switches off of it and wired in a set of remote switches right here, so I have the ability to start, stop, and reverse direction in a little handheld unit. And then I wired in switches for the fast, medium, and low settings that are on the board, which were normally just jumpered. And then this little dial up here is the little dash pot that controls the frequency output on any one of those three settings. It runs pretty well, and I can control it pretty slow. The only real problem that I've run into is that the stepper motor does not have enough torque. So my attempt to save a few bucks turned into giving me a bead roller that works, but it does not work as well as it could. I think the DC motor setup from Willwood or Eastwood is probably the best option. So this will run through. Get a little pressure on it. But what happens is it starts to skip, and the number of passes required to actually get a decent bead are a lot. And you're fighting with the missed steps when it just can't generate enough torque to move the piece of material through the rollers. Again, it does work, it's functional, but I'm gonna have to save up my pennies and eventually get the Eastwood motor unit. As you can see, the number of steps that are gonna be required to actually get a full bead on this. And this is about 37 thousandths thick steel. I'm sure aluminum would be a lot easier, but if I try and get into 18 or 16 gauge steel, I don't think it's quite gonna have the ability to move that material. So between now and then, I'm either gonna have to take it very slow or come up with a short-term different motor until I can actually pick up one of the Eastwood units. Pretty much gotta thank Carl Fisher for creating this and putting all the plans out there for free, because that is what allowed me to actually build this, which is something that I've wanted for a while. I did not modify any of the plans that he had, except I had 3-inch tubing on the shelf, so I made my base out of 3-inch tubing. I didn't need to make the caster plates because they fit right into tubing. I did modify the top plate here. Instead of just welding a nut onto it, I just made a block. Had to turn my own little handle. And then for the perimeter, instead of having to CNC plasma cut that out, I just used 2-inch flat bar, 1/4-inch flat bar, tacked and bent. Welded my gears. These gears themselves came off of my Harbor Freight unit. The rollers that I have and these lock collars all came off of the Harbor Freight unit. The only thing I bought from McMaster Carr was these bushings, all 4 of the bushings, and that screw. This 3/4-inch flat stock and all the other material I got from Metal Supermarket, including the cold rolled 1-inch bars. I spent, not including the base because that material was already in my shop, I spent about $600 on materials for this. Again, that doesn't include the stepper motor or the electronics, because again, those were things that I had on the shelf. The casters I already had on the shelf. So just in main materials, I have about $600 worth of materials into it. And that will go up as I can put away the money to buy the Eastwood unit. So that's basically what I got. For this portion of the video should basically be preceded by a bunch of time lapse of me cutting out the parts that I did have to cut out on the plasma table that I had made a few years ago. And that all worked out quite well. The DXF file or the DWG files all import really nicely, and everything cuts out and all the dimensions are right what they need to be. So again, thanks to Carl Fisher at Japhands Customs for putting out the plans, and this is my amateur result.